Hi everyone. Today we are going to put all of our transformations of periodic functions or sine or cos function together. Before we do that, we're just going to review what we talked about last lesson is our stretches, compressions, and reflections. First of all, we want to state amplitude, period, domain, and range, and then we're going to graph. So thinking about how we're going to set this up. Our amplitude in this case, again, is the A value out front, positive value of A. Our period comes from our K value. It is the inverse or the reciprocal of, so if it's 1/4, we're going to, and notice we're graphing in radians. So 1 cycle is normally 2 pi. We're going to multiply that by 4 because 1/4 tells us that it's a stretch by a factor of 4. So our period is going to be 8 pi, which tells us that our domain is, and notice also that we have our reflection. And I think in the last lesson we missed, or I missed that, when we turned it around. So we should go back and take a look at that one. Our domain of one of the last ones was negative to 0 instead of 0 to the positive cycle. And that's where we want to keep in mind that our reflections are going to change that as well. So if we think about our x values here, we know that our period is 8 pi, but it's going to be reflected around the y-axis, which means that x is going to be greater than or equal to negative 8 pi, but less than or equal to 0. And anything in between there. Our range is going to be greater than or equal to negative 5, less than or equal positive 5, and anything in between there. So, again, when we think about graphing, we want to think about our key points. In radians, our key points, 90 degrees or pi over 2, but we're multiplying by 4. So key points are going to happen every 2 pi. So we need to go up to 5, which in this case we can go by 1s on our y-axis. And we're going to go every 4 blocks is 2 pi. As always, we want to label our entire grid, even though we're not going to have to use the whole thing, but we want to make sure we have it graphed appropriately. So, again, noticing that we are using cos. So if we want to start by doing our base graph without our reflection, we can do that. So at maximum for cos, which is 1, but we have a stretch to 0, and key points happening every 2 pi. So that's our graph of y equals 5 cos 1/4 x. So now our reflection in the y-axis means that we are going to move all of our points from the positive x values to the negative x values. Now, notice that when we do this, we notice that our reflection around the y-axis is the same graph because we started at the same point, that 1 on the y-axis, and which meant our reflection reflected itself right on to the other side. For part B, y equals negative cos 8 theta, and this time we're going to do in degrees. Our amplitude is still 1. There's no other a value up front. And remember, we always talk about it as a positive value. It's a measure of height. Our period, which is normally 360, is now going to be divided by 8. So we're going to have 45 degrees. We do have a reflection in the x-axis. Now that's not going to change our domain though. And in this case, it's not going to change our range, but we'll look at that a little closer in a second. So x has to be greater than or equal to 0 degrees, but less than or equal to 45 degrees, and can be anything in between. And again, we're just talking about this one cycle, not the entire function. And our range, we don't have any transformations up or down, so we are going to stay with -1 and 1, because our max of 1 reflected becomes min of -1 and vice versa. So we want to now take a look at how we're going to scale our grid. And so our domain should be in theta in this case. So our y-axis, we only need to go up to 1 and down to -1. So we can use lots of space. Now our key points are going to be a lot smaller. So our key points were normally 90. We're dividing by 8. So our key points are actually going to be 10 point something. Well, instead of measuring every 10 point something, what we can do, as long as we go in even blocks, so we can still think about every 4 blocks are going to be our key points. But now we're going to measure these. We know this one's going to be 22.5 or half of 45, and this one's going to be 45. So we can still, we know that this is going to be 11.25 in here, but we don't necessarily have to have those decimals, all of those decimals on our grid. Now, again, if we want to think about our key points before the reflection, we would have started up here to the middle, to the bottom, to the middle, back up to the maximum. That's our graph of y equals cos 8 theta. Reflected in the x-axis, now we're going to start at our minimum, to the middle, to the maximum, to the middle, to the minimum. And there we have our graph of y equals negative cos 8 theta. So when we talk about our base graph, we want to think about how all of these things change our base graph. Notice that if we have a k in here, we have to factor that out first. So we're going to have a sine k comes out of the bracket so that we can truly see what that number is in there with theta. And now we can talk about our transformations here. So our a value out front here gives our amplitude, which is the absolute value of a. It also tells us whether we have a reflection or not. Our k value in here gives us or helps us calculate our period of 2 pi or 360 over k, or 2 pi times k, or sorry, 1 over k. And if that was a whole number, then we would do the reciprocal. So K also tells us how many cycles occur in 2 pi. So be careful with that as well. D is our phase shift. So left or right. And C is our vertical translation. Up or down. And let's put in here left or right. And again, these all happen exactly the same as they do with any other function. So let's take a look at a couple of examples here. So our first one we want to pay attention to, first of all, our amplitude is 2. What we have to do in here is we're going to have to factor. So we have to take our 4 out. And when we do that, dividing by 4 or multiplying by 1/4, we're going to get, and let's do this over here. So 2/3 dividing by 4 is the same thing as multiplying by 1/4. So we're going to simplify. We get 2 down here, 1 up here. So we're going to get pi over 6. So we're going to have theta minus pi over 6. And we have plus 1. So now we can see this 4 here. We're going to take our period of 2 pi, and it's going to be multiplied by 1/4, 1 over k. So we're going to get 2 pi over 4 or pi over 2. Vertical translation, up 1, or plus 1 at the end. Our phase shift is right pi over 6. So, thinking about how we want to scale this. Our max and our min, we can think about with our amplitude. Normally max would be 2, but we're moving it up 1, which means we're having a max of 3. Minimum -2, but we're moving up 1, which means -1. So on our y-axis, we need to go to 3. On our x-axis, this gets a little more complicated because we need to be able to move pi over 6, and our cycle is going to be pi over 2. So we want to be able to move easily pi over 6. So moving pi over 6 means that we want 1 or 2 blocks or 3 blocks to be worth pi over 6. If we made 6 blocks pi, let's just say, so 6 blocks is pi. That makes it really easy to shift 1 block. But our period is only pi over 2. So that's not going to spread out our information enough. So perhaps we want to go every 12 blocks. Well, still not going to make it very big. So what we want to do then is make 24 blocks pi, because we only have to do 12 blocks is pi over 2, which is our period. So where we're going to start here is to just graph y equals 2 sine 4 theta. Okay, so first of all, 12 blocks, 2, 4, 6, 8, 10, 12 is going to be pi over 2. Half of that, 2, 4, 6, then is going to be pi over 4. pi over 2 divided by a half, or sorry, divided by 2 or multiplied by a half. So 2, 4, 6 is negative pi over 4. And this is where knowing your fractions is really going to make this a lot easier. So key points then are going to happen halfway in between. Remember, our key points are spaced evenly, starting at 0, 0, up to the max, which here, remember, we're just going to start with y equals 2 sine 4 theta. Back to the middle, down to the minimum, back to the middle. Okay, so that's our graph of y equals 2 sine 4 theta. Well, now we're going to take those points and we're going to move them to the right, pi over 6. And remember, pi over 6 is going to be every 4 blocks. So 1, 2, 3, 4, and up 1. Now we can think about our key points, or we can think about moving point by point. 2, 4, up 1. 2, 4, up 1. 2, 4, up 1. 2, 4, up 1. So now we have our graph of y equals 2 sine 4 theta minus pi over 6 plus 1. Okay, so there's a lot to think about when you're going to graph it, what you need to put on your grids, and so forth. Okay, so you really have to think about what your max, min, amplitude, phase shift, all of that are before you start. Part B, y equals negative half cos negative half theta plus 540. So here our amplitude, positive value of A out front is 1/2. Period comes from in here. Now again, notice we're going to have to factor out that negative 1/2. And when we divide by a half, our number gets bigger. So we're going to, this is going to become a minus. And we're going to have minus 1080, and we don't have anything at the end. So our period is, and in degrees we're going to do it this time, so 360 degrees, but we have a 1/2. Again, just thinking about the 1/2, this means we're going to be multiplying by 2, opposite of what it looks like. So our period is going to be 720, but we're moving it. We're going to have a phase shift to the right. $10.80. And we have no vertical translation. So looking at how we're going to scale this grid, we also need to remember that there's 2 reflections here. We have a vertical reflection and a horizontal reflection, so we're going to have to leave space for that, and moving 1080 as well. So drawing our key points, we want to leave lots of space. We only have to go up to 1/2, down to negative 1/2, And our key points are going to happen every 180 degrees. Because we want to make sure we have lots of room to move, we're going to keep it smaller. So we're going to do every 4 blocks is 360. And another 360 gives us our 1080. 360 gives us our 1440. And we're going to start by graphing y equals 1/2 cos 1/2 theta. Then we'll worry about the reflections. So we start at the max, our key points every 180. This makes sense because our period is 720. So y equals 1/2 cos 1/2 theta. Now we're going to worry about our reflections and our translation. So from these points, we have a reflection in the x and y axis. So y becomes -1/2. 0 doesn't reflect, but now we need to move it 1080 to here. Next point reflects around the y-axis and the x-axis, but again reflects over 1080. And remember, our key points are every 180, every 2 blocks. So we can think about whether they make sense that way as well. Next point reflects around the y, but also the x and 1080. Reflects around the x, then the y, but over 1080. And we have our graph of y equals -1/2 cos, -1/2 theta, minus 1080. Okay, so you really have to, there's a lot of work here to figure out exactly where the points are going. And I would go in shifts, first of all doing your stretches and compressions, and then you can use your translations and reflections. Now, last question here, example number 3. We want to come up with an equation for the following function. First thing we're going to do is draw a line in the middle of our graph, because either of our functions, y equals cos theta or y equals sine theta, should be centered on the x-axis for our base graph, which this is. So this tells us that there is no vertical translation. Our y equals sine theta starts at 0, 0 in the middle, which this does, so we're going to use sine. We're looking for our period, which is 1 full cycle, ends here, which means our period is pi. Well, if we want to figure out our k value, our period is equal to 2 pi over k normally. If we think about switching these two values, k is equal to 2 pi over period, which means 2 pi over pi, which means our k value has to be equal to 2. So we have our vertical translation, we have our k value, we take a look at our amplitude, half of the height of our graph, or our max minus our min divided by 2, which means our amplitude is 6. Now we just need our phase shift, and because this starts right at 0, 0, there is no phase shift either. So subbing those values into our graph, remember we need our A, K, C, and D values. This can be graphed as or labeled as y equals 6 sine 2x. Okay, so you look at the properties that were on our